All right, we have 30 or so people. I think we can go ahead and get started. Over to you, Johan.
Thank you, Andre. So, good afternoon, good morning, good evening to everybody. Hello, colleagues. Welcome to today's session. Before I start, I hope you can hear me all. In case anybody has issues, let us know. Good afternoon. I wish to welcome you to today's session of session number 4 of the DFX Academy, where we are going to be dealing with geospatial information, data, and maps. Thank you. We already had this session, and we kind of try to incorporate, the feedback that we get. So from the last session, the feedback was there was indeed too much information. So this time we are going to be taking a slightly different, approach, in a sense that we curated a little bit and limited the amount of information, and we are going to focus on much more on practical part, because maybe it's with these practical things, with this some of the abstraction that we are going to use, it's better to see things happening in front of us. So with this being said, I'm going to start sharing my screen, and I'm going to, Andre, please, can you share the link to the GeoHub so everybody can start, everybody can basically open the platform. All right. So as you can see here, what I have on my screen already is the GeoHub documentation. So essentially, I'll start by saying that me and my team, currently only my colleague Joseph, are responsible for developing and designing this platform. And our goal was to create a open source based geospatial platform to help you colleagues create some sort of maps and get insights that are related to leveraging spatial data in your daily work. Now that sounds very noble and nice. However, it's a long story and a long path to get from the idea to a practical example. So I think you can now open the GeoHub. This is available. The platform is available at geohub.data.undp.org. It's a relatively big system that consists of completely disconnected, isolated components. So that means that these components are not aware of each other. We are just using them. We are leveraging, all the platform is leveraging the Azure. So we're using a Kubernetes cluster to power geospatial services. We host the data in the platform in Azure Blob. And we use also a dedicated Postgres database to store various configuration and metadata about the platform. So, it's a very, the platform, I hope it doesn't, it has a couple of sections that correspond mainly to what we are going to be dealing. Concretely, today we're going to be looking into the geospatial types of the data types, and we are going to create some visualization, which translates to creating some maps. But before we go there, there's in the support page, in the support menu, we have the documentation link, we have the source code link, and if you open the documentation, which I'm going to do right now, okay, this is the manual that we created, or the support page that consists of information organized in various ways. So today's presentation and talk and all information is available in various sections of this menu, of this documentation section. And what is interesting that when my colleague, we created something like, we wanted to have one system and one location to hold all documentation related to GeoHub. So we created, if you look at this button here, there is this something called presentation mode. So this is if I click on it, I basically enter a kind of, this is what I'm going to be using as slides. I don't want necessarily, as I said, my focus is going to be show you, not talk slides, but all the information that we are going to have here is available here. If you use your keyboard, your arrows left and right, you can navigate. In the bottom section, you can see these blue arrows here with the mouse. If you see 1, 2, those are slides numbers. Sometimes the slides are also vertical. There is a menu to navigate it. At the top, you have the menu to go back. So for example, if I click on importance of GIS and I click the presentation, this is where we start. So before this, yesterday I talked to Andre, and I was interested to know from what domains you come, what kind of work you are doing. So he gave me some graphs, and that kind of gave me a little bit of picture. So I saw that many people are working in the policy, some are working in the monitoring, and in general, there is information, you're interested in learning this more about geospatial and learning how to use this platform. So in general, I would say within my experience, in UNDP, you either are going to be dealing with some various type of project that are related to spatial planning. You want to know where things are going to be put in space in some of your projects. Some of you probably are working even in disaster risk reduction. This is another area that is successfully powering, the geospatial is successfully used in this domain because it provides new insight. This is about analysis now when we apply geospatial to disaster risk reduction, but also other colleagues. I know that we have colleagues from health teams that are using geospatial systems. So these are a couple of areas. Just and last but not least is obviously the climate adaptation and change, which is pertinent issue in today's world. So these are the main areas where the geospatial information. And when we develop GeoHub, we try to design it so we address possible kind of pathways and design it in a way that it would suit these kind of goals. Obviously, there will be conflict and many of you will not be happy maybe with the way certain things are. We can always change and incorporate things, but what I want to outline here that this platform is generic and it's supposed to be used by a lot of people. That's why it was designed to be for example, scalable, to work in the cloud, but also not to be too peculiar about many things, and that comes with advantages and disadvantages as well. So I will start by, in today's discussion, we're going to take a look at geospatial data, and then we are going to be dealing with visualization of geospatial data. But I want to take it really slowly, and I want to go in depth in some things rather than show you these slides, which you can always switch to presentation mode in your browsers and just navigate the slides so you can see what we are going to touch. At the same time, I prefer to basically go directly to the platform. So when I open the platform first, you notice that we have a menu at the top, right? So and when we have in this menu, we have entries like data, the maps, and various solutions. So first of all, GeoHub was designed to host geospatial data. It is possible to upload data. You can see here, there is a menu here where I uploaded some layers. And there is a lot of data sets. Not all of them are of value, but there's a lot of data sets. So what I want you to remember that this data section, of course, maybe I should have started saying it. I'm already logged in. You should all log in, otherwise it's not possible to get the full functionality. The login is available from this top corner here. So let's get back to data. The data section is supposed to, it's accessing a repository stored in Azure Blob for those who are interested, and that's all we need to know, and a database. So it's a kind of interface powered by some backend services. And what we see there are various curated geospatial layers that are tagged, they are designed, and the most important thing about this data is that it's searchable. So you can also change, switch to a card view where you can see some preview, which many times is not necessarily very useful because it's something automatic. We have automatic way to visualize things here. So I personally prefer to go to list because it's much faster and to display as many of them. But we do have one of the main functionalities to allow us to, basically search all the data. So what I'm going to do here, I prepared, instead of going to the presentation and start dealing with all these data type, we're going to go directly and I'm going to load for each type of data that we have in GIS, I'm going to load a layer type. So probably most of you are familiar with the fact that we do have points, lines, and polygons, and we call them vector in the geospatial jargon. So they are characterized by crisp boundaries. These data types are characterized by crisp boundaries. And the way I want you to imagine, you can see the attributes part. Imagine that if you have a Excel, which all of you are familiar probably with Excel, and you know that it's a table. If you add coordinates like latitude, longitude, you converted that spreadsheet into a geospatial layer because it can be interpreted as a point layer on a map. Every location becomes a point with a symbol on a map. So that's the most basic type of data. It's the point type of data. So let's move. And I created this. If I type health sites, I have to type health sites. You can see that there is a data set here. So I'll take a little bit of time now to explain. I'm mixing things between the data type and maybe visualization as the data storage. So the data storage section, features these data sets or that contain one or more layers. Usually, we have one layer per every data set, but there are exceptions. So we have multi-layer format. That means that you will see more than, you will see another dialogue in some of them where you can see inside this data set, you could see lines or maybe other type of points or something like that. So this is what we see right now is a basic visualization, a default visualization of the first type of data of the points. There's what GeoHub does in an interesting way is that because it was built on open source, it has a section here called share links, and it says for developers, but this is not necessarily only for developers. First link there is a link to the data set itself, basically, which is my link here on the top. Then we have an automatic preview, for example, and an interesting thing is that if I open this in a new window, if I just clicked on the preview URL, okay, and I'm going to be, of course, I got an error. So what the preview link does, it's, if you look here, it has a template. So it wants, if I want to render a picture automatically, I need to replace this URL here with, I'm just showing you some, maybe some, 200 pixels by 300 width. Yeah. This is supposed to render. Now the data set is supposed to be rendered automatically. Now let's see whether I'm going to be okay. So this is how, for example, if you have your data set, let's say you want to reference a data set, by using these simple links here in the data section, you can directly create automatically a picture of the data set and then, reference it, put it on your website or stuff like that. So some of these things are very useful. What I showed you is some automatic rendering, the one that was available under cards. That's exactly what happens when you click the cards button. Each data set is each data set is rendered automatically. So this is the page. There's a section related to permissions. So I'm the owner and I can control various permissions, and I can also change the way these behaves. So more or less, we touch the first here. What we touch with the first type of data, which is a point. But you have to remember that if you have tabular data and you attach geometry, it becomes basically a geospatial point layer simply if we put latitude longitude coordinates. But if we move forward, okay, thinking about the data types, that we start linking points together, we start creating lines, and obviously what comes to our mind is a river layer. So it becomes a bit more complicated because we have to store now internally in the data format also which node is linked to which node. So that's how we know how to draw it in the software. But basically, by combining these lines, we enter points, we create lines, and then by applying some rules that how we draw and how we represent polygons, we combine lines into polygons. So this basically what I touch here are the main the main vector data types. Aside of these data types, you can see here in the middle, in the second column, we are displaying the web page shows satellite pictures. I think all of you can recognize satellite pictures. Now, as opposed to the first type of representation, where we have point lines and polygons represented through crisp geometrical boundaries, the second type of data, it's a big category of data. It's what we call raster. Again, you probably are familiar with it. So what is the difference between these two? They are very, very different. While the first category that we saw, the line, points, the polygons, you can see a lake, for example, it's very clear where the lake ends. Although the same border it's visible on the satellite, when you think about raster, for example, precipitation is something, or temperature. Every point on the globe has a precipitation. So for displaying phenomena that are continuous, you always will be looking for raster type of data. So if you want to make a map with precipitation, with temperature precipitation, with any type of natural variable or social variable, economic variable that is continuous, that means it has values everywhere, some of them over the oceans as well, like temperature. You would be using raster type of raster data. Otherwise, you probably will be using vector type of data to show these crisp boundaries. So let's go back now to the system. You know that I'm inside the data, and we looked at this. Okay, we looked at this point layer. So what I want you to do, in case you are around here, is to actually add this layer to the map, because we are going to be looking into something that everybody assumes is the simple thing, and that is the map object. So what I did by clicking on the button, that layer, that geospatial layer was open, and we can see that it's showing on the map directly. So right now we have basically there is a Tor functionality in GeoHub, which we have developed, and I'm going to take it and explain you as it was meant by our colleagues and developers who created it. So What we have here, we have the platform consists of this sign-in location is the first one. You can see my name here displaying with my icon, with initials that I'm logged in. We have the application now consists of a data section. So the data is available from inside the map and as a portion of the system itself. Now, why is that? Because we do two things with data. We consume it, and this is, for example, easy to consume it in the map directly, but we also can upload data to the system, and that has to be done from the data section. That's why we have two links. Next, we obviously have we can there's a menu here to upload and search the data set with various keywords. We have the layers. This is a part of the map application where we can see where we can see what layers have been loaded. And in my case, there is this layer that I already loaded there. And then there's various there's various images there's various other icons that we have on the map. So the sidebar contains this data section, which allows me to interact just in the same way like I interact here. I can consume easily. Then I have the layer list basically to organize my layers and save the map. And then we have the main area section. So one of the things that is very overlooked, if you look for a location anywhere on the map, you can actually search. So if I type at this and just press at this button, I already get some pointers. This is very important. It's very simple, but very important and very easy to overlook. So we have a service here on top, which allows you to search for various locations and drive the map towards your location of interest. On top of that, we do have these buttons here. So these are quite interesting. Maybe it's not very let's say, if you find this very, very simple, please excuse me. But I really wanted to take my time and go through all these icons and make sure that the things are because I don't think everything is very obvious. So some of you maybe are aware that recently we had some issues with borders. There was a problem with borders, there's various situations globally available. So we have upgraded the system to use more or less UN official maps, and we have several base maps. The base maps are available here in this widget, and you can see the green one is the one that is selected. So we have these are public map they are public base maps, and some of them are interesting because maybe for some type of data there might be some are better suited than the other. For example, if you have very, very like not color data with little variability, a black background map, for example, can be very expressive and very useful. While on the other hand, if you have a lot of information with many, many layers, you might even choose to do something completely crazy and switch to a backgroundless map. Basically nothing in behind. On top of that, somewhere in the middle, we have also satellite imagery. And you can see that as I zoom in, it becomes much more detailed. So it changes with scale. These all base layers are available from this widget. And I want you to know that we have them there for a very simple reason. In general, they are very fast, very crisp. That is one very important thing. They provide spatial context. So depending on your goal, like I said, if you want to create a map with only white lines, you might be better off using this black thing and laying them down, or basically it's a matter also of preference. Okay, so this is one very important thing, one very important widget. Let me switch back to default style. And now here we have some tools that allow us to draw things on the map. They are very basic. Okay, so what I'm going to do, I'm just going to basically I create some points. By default, you see their altitude automatically. and distance. So these are some widgets that allow you to create graphics. These are not real geospatial data and objects. You know, they are basically just graphics. So I'm going to delete now all the graphics that I created. I'm going to collapse this by pressing the top button, and we have something called hillshade. So probably this is not self-explanatory. You actually need to be quite a specialized. You need to have specialized knowledge. When I click on this, and when I please try to click, you know, you can click as well. You'll see that basically our map becomes suddenly terrain aware. So with this switch here, you enable and disable the terrain. Depending on what you want to show, or depending on your aesthetic style, you might want to use this as well. And there is also, so we have this hillshade, which is a technique in geospatial science to use shadows to suggest terrain elevation. And then we have something called like enable terrain. And this actually did nothing in reality. You know, when you look at this map in 2 dimensions, this second button here appear to do nothing, but it's not. This is not the case. If you start moving your mouse with the right button, okay, you realize that the map becomes in 3D, and this compass at the bottom is an indicator to the 3D map. And if you start zooming in, then you can see that this terrain actually is actually, you know, this button with terrain has an effect. It actually exaggerates vertically the terrain. So why is this useful? It allows you to overlay various type of data in a very much realistic context. You can see, for example, my points suddenly appear on top of terrain. They respect the elevation of the ground, and everything looks very realistic, especially when you want to create cartograms or 3D views and you are dealing with things that belong in nature, land use, or you simply wish to provide this type of context. The 3D views are very, very useful. Okay, so let's disable now the terrain, let's disable the hillshade, and let's click on the bottom to reset the map to 2 dimensions. Okay, now one of my colleagues has created also the globe mode. This is quite interesting at the same time. If I click the globe mode, our map suddenly becomes a globe. So if you have global data that is not very high resolution, it's also possible to use this option to provide, in some instances, this might be very desirable, actually, and in some might be very required. So there is also an option to display the map like a globe. This is still pretty new functionality. I think I kind of have covered, you know, most of the this map. We haven't done it because we always assume it's very simple. But I wanted to take this time. I wanted to go and you know, make sure that it's clear what we have here. And there is one more widget on the map which is very tricky. So, for example, below the search, depending on where my mouse is, you can see a widget that indicates where my mouse is right now. So if I go to Iraq, basically you can see there's 3 levels of information. I'm in Iraq, I'm in Salah al-Din and Heat right now. So this is a widget that gives you a location very much understandable and used in development work and project. Because one thing is to know the coordinates where your mouse is, but every coordinate corresponds more or less to a political entity, administrative entity, and we can see the full hierarchy as we move on the map. Obviously, when we go over a sea or something, this disappears. This actually goes away. So so these are probably, like, I think I give you you know, a decent overview. There is one more information. There's one more button here still. This button is to use the query the data point. So when we click this mode, when I click this button, it make it green to be enabled, and I click the point, I actually get information from the points on the map that I loaded from this layer. All right. So I think we went through all this mapping interface with all the buttons. The most important thing here to remember is there's a lot of options. Some of them are computationally demanding. So enabling this hillshade and terrain requires a lot of other data in the background. Remember that it's not instant depending on what you do, and depending on your internet speed might take some time, because whether we realize it or not, when I click this green button, I'm fetching a lot of data to provide the terrain tiles underground. It's fast, but it depends actually on the speed of my network and sometimes on the speed of cloud and how the state of the cloud services, how they work. This panel here, I didn't actually work at all. I just said that it contains two tabs, right? It's expandable. You can close it, and we have this data and layer section. So within the layers, everything we bring from the data store, it's already, this is a container kind of location where then we interact, where we interact with this. All right. So I was looking at the time, and I believe I'm going to ask my colleague now to prepare, because he's going to talk from the data section. We went through the the data points, and he's going to start now, and he's going to give us a small visualization, the introduction into the visualization of raster type of formats. One more thing before I pass Joseph, before I pass the screen to you. One thing that I want to highlight here is that recently the geospatial data is currently in a revolution, and this is something almost technical, but it's important that you are aware. With the development of cloud and cloud system, with artificial intelligence and all this, the geospatial data, and there's more and more geospatial data. So there's a natural need to consume it in large quantities. And for those reasons, many of these data comes with cloud-friendly geospatial formats. So some of these are noted here. So what is the difference between if you have an Excel and you put coordinates, it becomes a geospatial layer. What is the difference between that data file and a cloud optimized? It's the cloud optimized data formats, whether you can store point lines and polygons or rasters in some of them. They are designed in a way to be easily streamed over the network. So they are going to be quite complicated, and they require a lot of expertise. That's why when you hear terms like cloud optimized geotiffs, you need to be aware that those are just simple TIFFs with a lot of other metadata that makes them streamable nicely over the network and much easier and much nicer to work with. But they do require a lot of knowledge, as opposed to a simple TIFF. You might have a satellite image in a TIFF somewhere, or a picture or something in a TIFF. It's just a basic image. But the cloud optimized GeoTIFF contains a lot of metadata. So that's the last thing I wanted to say before I pass the screen to my colleague. So Joseph, please you can share your screen, and I stop sharing now, and you can start with raster.
Okay. Yeah. So in my section, I'm going to describe and demonstrate how you can visualize raster data on the GeoHub system. And the first thing that I want to show basically how you can basically flow from the homepage all the way to where you go, where you get to the point where you actually visualize all the data sets, the data set that you have, the raster data set that you have. So on this homepage, there is on the top, there's this data button here, or in the navigation bar, that you can actually go there and access any dataset that you have either uploaded or any dataset that currently exists in GeoHub. And I'm going to show a data set that we call GHSL, which is essentially a global health settlement layer that essentially shows the population estimates for every pixel. So I'm going to select a data set for 2025. And once you open this data set, you're going to see all that information, the information related to the data set. That means the title, the description, and you can also preview that data and also some other extra information related to this data set, including things like resolution and basically, and you can also, there's also a download button here on this part where you can actually download the GeoTIFF. Yeah, and also information like licenses and source and things like that. And when you scroll down, you're going to see an add to map button, which when you click is going to open a new page, and that is the maps page, where you're going to see that data set on the map already basically just visualized by default with the default visualizations. By default, that data set is going to be shown with a continuous legend, which is basically what you can see currently. And on this page, you're going to see there are several buttons on this page where you can interact with features related to this map, where you can, for instance, open settings for visualization, which are these. I'm going to talk about them in a few minutes. And then you can turn off or turn on the visualization, that is to show the visibility of that layer. And you can also see this menu button here, where you can zoom to layer. You can, if you have several layers, you can also basically turn off all the other layers that you have. You can also rename the layer. Basically, when I click, I'm able to rename that layer, and then I'm also able to duplicate, that is make a copy of this layer, and I can also remove it from the map basically, and from this list. Yeah, and you can also delete that layer that you have, all the layers that you have from this button. You can collapse if there are multiple layers that are expanded. You can collapse them into them. You can collapse all of them. So I'm going to explain now about the visualization of this layer. In this is a raster layer, which means it's a pixel-based layer that we have in GeoHub, and we can show from this page here. There are also several buttons where you can also zoom to layer. That is, if I zoomed out, for instance, and zoomed in, if you click that button, it's going to show the whole extent of that data set where it covers. And I can also, this button works the same, where I can turn off and on, and I can also change opacity of this layer. That means basically to show to show if the opacity, to show the opacity of this layer. And yeah, so from now this, I'm going to explain now the legends that we have. We have two legends, which is in GeoHub we have simple and categories legend, which this means the simple legend is where I show this layer as a continuous layer. That is, every pixel are shown over a range of values, or rather the colors are assigned over a range of values. And also for this, and I also have this categories layer, categories classification, where I show for every range of pixels, it's given a specific color. Yeah, I'm going to show, for instance, this categories layer, how it looks. And from these categories, you're going to see that there are several classes that are basically created from this layer. So, and each of these classes are each assigned their own color, and you can actually change the classification method that you want. And because this layer is actually very skewed, as you can see, it's very, very skewed. That is, a lot of the visualization, or rather, a lot of the colors appear to be similar, you can change into a maybe a different classification method. I'm going to select logarithmic, which is actually good, really good for this type of layer, where you can see different classes that are going to be generated basically from this classification. You can also change the color that you want. We have sequential colors, which we have sequential colors, and we have diverging colors, and also qualitative. And for this layer, I'm going to use diverging color map to show basically where this how this population distribution is in this data set. You can you have the ability also in GeoHub to increase the number of classes that you want. You can increase the number of classes you can increase or reduce the number of classes that you want, depending on your specific use of this data set. So I'm going to reset it to 5 for my use case here. And then, yeah, from here now, you can actually also query this data set. For instance, for specific pixel, you can, for a specific pixel, you can also query this data set and see the value, which is in that specific pixel. And you're going to see that in this data, for instance, here, you see the 0, which lies in this class. And also here, you'll see, let's see. Yeah, you basically, I don't know, yeah, you're going to see basically the value of the specific value of this point where you have clicked. You're going to be able to see all that information. Yeah, so and yeah, you can also see information also about this data set from this info panel here on this page, and also the statistics, which is going to show basically statistics about the data where maybe the number of pixels which lie in on a certain range. As you can see, this data is very skewed. That's why you can only see one bar here on this. Yeah, that's why you can only see one bar, which means that 93012 pixels lie between 0 to 5332. Yeah, so yeah, and there's also other options that you can use for basically changing the way you visualize this data. We have this rescale. We have this rescale functionality, which basically will help you to change the way you actually you can change basically how you visualize that data set. I don't know why. Let me refresh.
I think Joseph, you have to let's take it slowly. Let's not rush, because this is not going to help anybody. So I'm just let's please visualize it back, and let's focus on the main style of how we represent this data.
Yeah, yeah.
Okay, open please yes. And then so we have, when it comes to the raster data, by default, can you switch back to the simple, to the continuous representation? Exactly. And put choose a linear, choose a non-diverging, choose a simple, choose a primal, a sequential color. Yeah, a blue one. So for example, the population is a variable that is very skewed. So please go to the info, and let's take a look what that skewness means in this concrete case. So we have first of all, I think we failed to say at the beginning that the properties of a raster layer lay down in, we have a style, a transformer, and information. So the information, the info tab contains statistics and metadata related to the data set. And although it sounds very maybe unintuitive, when you look at this histogram, for example, And what does the histogram mean? It means that we took all the pixels and we put them into some groups of values. The population is, this data set represents essentially the number of people in every pixel. In this case, a pixel has 1 square kilometer. So it's the number of people that live in every square kilometer. As you can imagine, most of the globe is not populated really. That means that we have cities, we have villages, and the density of people is varying fantastically from towns, from mega cities like Cairo, Ciudad de Mexico, where you have thousands of people in a square kilometer living, to desert where literally Antarctica, where nobody's there. That means that we will have most of the values, most of the pixel in the data set, they carry no value because they are empty. That's why we see this one bar actually. There is, most of them are, if you zoom in, please, zoom into a city, for example, zoom into Nairobi, let's say. You can see a little bit of pixels there. But in reality, so here in this simple type of visualization, we can see that there is some population there. But in reality, all the population is concentrated around the cities. So the distribution of these variables, statistically speaking, is not natural. That's why, if you go back to style, okay, and use rescale, click on the rescale. Okay, now, so what happens now? We map the color, we map them to the whole range of possible values, okay? And if you stretch it to the end to include the color map, to include the whole values and zoom out, we can see the effects, we can see the effects of this. So basically, we are mapping the variable from low to high. We know only the intervals, and we map it to a color. Click on the color pack. So we map it from white. You can see the legend basically from white to dark blue. But then the rescale allows us to map actually non-linearly this and force the color to be assigned instead of the maximum density value, force it to, I don't know, 5,000 people per square kilometer. Click on rescale, please, Joseph. And yes, and move the bar to 5,000. So in this way, suddenly our visualization will change because we mapped actually, and you can see already there's more points. It suffices to go to a city now and we see, okay, there's more pixels that are becoming blue. And like in India, you can already see there's a lot of people living obviously there. And you can already see the map has changed dramatically. So this is a way to handle, for example, a very skewed statistically variable. Now, you will know probably if you're interested in working with data, there's various type of distribution, and the Gaussian distribution is the most widely known in our universe probably and our work. However, this data set doesn't fit. That's why we have this issue with display. By default, if you stretch it to the maximum, and we say whatever is low population becomes white, whatever is blue becomes maximum 58,000. Sorry, 5,000 there it's the maximum. No, actually 53,000 is the maximum somewhere in Cairo, or I don't know where, on what street. That is not a good way to visualize. That's why we use these tricks to non-linearly map. So instead of going from 0 to maximum, we use the colors to a small part of interval where most our values lie. So most of the places on Earth will be somewhere around to 5,000. That's why you can go and type, can you go to the population count and type directly 5,000 in the box? There is a box there. So you can either type it directly, so then your colors are actually, so it's like you're kind of ignoring the rest, ignoring the rest of the data. And why do you ignore it? Because it's empty. Nobody lives in Sinai. Almost nobody lives there, right? So that's why we need to use some tricks related to visualization to be able to display this type of data properly. The second type of way how we can handle it is it's not to use a continuous display as it was naturally perceived, this phenomena. So we changed the display type to a categorical based, please change it, Joseph, to categories. So what does this really do now? Every pixel has a value in the map. Every pixel says how many people live there. That means that when we can now split and we create aggregations. So we have intervals, and if every pixel will get a color according to intervals, the number of intervals, which we call classes, and the method where we make the intervals are really controlling very much our display. So if you go back to equidistant, for example, click on the equidistant, Joseph, on the method. Basically, we split the whole domain of data from 0 to 50,000. We split it in equal number of classes. You see, in every class, there's the same, like you have this, the values have been split. Obviously, the number of pixels that fit in each class is very different. Between 0 and 500 is 98% of the world. But then this is what makes the skewness, like I said, right? So again, this is an interesting visualization. Can you close the query button, please? Yes, this is an interesting visualization, but still it doesn't show us the fact that in Cairo there's like thousands of times more people compared to the Sinai. It's still not good enough. Now, why? Because we choose to distribute this equally, but the data is not equally distributed. It's logarithmically distributed, exponentially distributed. There's one person in Sinai, 1,000. For every person in Sinai, there's 1 million people in Cairo, or 100,000 people in Cairo. So that's not a linear relationship there. That's why when we change the classification method, it will change the way the intervals are designed. So please click on any other type of classification method. And for example, quantile. So this uses now some statistics, and you can see the intervals have been changed already. But this is not ideal. For some variable might be bad, might be good, because we have another method which is called natural breaks. Please click on the natural breaks. This one is designed to maximize the difference between pixels between classes and minimize the difference between neighbor pixels inside a class. Now, why this doesn't produce maybe the expected, you would expect very crisp boundaries and very nice visualization, but it's not exactly the case. And I will explain you why. It's very simple. There's millions of pixels in our map. Please zoom in. Please zoom out to the whole layer extent. If this map contains millions of pixels and we are displaying all of them at once. So if we wanted to compute statistics, I would need to iterate and check each one of them. So I just design a method. We design a method inside GeoHub to kind of trick it and go around and approximate the statistics, because doing statistics in real time is something we do on our desktop systems. On your computer, you install a software with GIS, and that one will give you all the data. But when you click classify, it will take 2 minutes sometimes to classify. We don't have 2 minutes in a web environment. There's a lot of computing power necessary. Browser is not a good environment. So we trick it and we approximate it. But yet, then but for example, by looking at info and the statistics, that tells us that it's very skewed. And if we select now the logarithmic, and please select the logarithmic, and this is why this will produce the best results, because it actually is really fitting with the nature of the data. These are the most widely used classification methods, where pixels are bucketed and are grouped together into clusters that are similar to each other. And please zoom in now and zoom into Cairo, and we will see now, in fact, that Cairo is much more populated compared to Sinai, because we match the distribution, the natural properties that are found in the data. So these tools have been designed. You see already there is inherent complexity in all this talk here. So we talk about simple linear stretching where you manipulate the interval to get better results on visualization. Then we went to categories, and we saw that we can use various methods to create intervals and bucket the pixels so we get better, for example. And then there's one more type of data which Joseph will show us. Let's take a look at some unique value type of data. So for example, if you think about land use, right? Land use is generally acquired these days from satellite data. You have a finite number of classes. That means you have seven, okay, you have seven classes or 10 classes. Now, Joseph can show you how a legend for this type of data looks like. You can see anthropogenic biomes. As we loaded them, each color has one value, and there's like 9 or 10 classes, 15 classes. It's not important. It's important that with this data, this is categorical data. So we have continuous data. We have continuous data can be then broken into intervals to facilitate our understanding, to see clusters in space, see pixels that are close together, see how urban areas differentiate from desert and stuff like that. And then we have categorical data, which is different. And you cannot do any type of statistic. This doesn't have a minimum maximum, right? Urban is urban. We know that it's a village. So these are the three main types of raster data. Inside the raster category, we have we use this type of visualization, and each visualization matches and is used for its specific data type. So in essence, when you want to create a map, you have to think, okay, what do I, in terms of raster data, if you want to work out with this data, if you want to create a map of that data, you have to think, is it continuous or discrete? Is it categorical? Because based on that, the system provides me as a user with right tools or whatever we thought is right to facilitate, for example, naturally to facilitate and help you with performing good visualizations. Okay, I think we have exhausted the raster, the raster data types. At the bottom, if you collapse, there's a lot of other like options there, but they are too technical. I personally don't find them very useful for you. Joseph can, for example, demonstrate what contrast would do. The contrast, for example, if you go to the style contrast, Joseph, please. Yes. And see, like demonstrate what is the contrast doing. You see it's set at 50%. So you basically, if you zoom in into an area, and let's see what it does with these pixels and with this data. This is mainly used for satellite type of data. It doesn't have any effect. So you see, like, okay, the crispness and the intensity of colors has been increasing. But with this type of data, it doesn't make much sense. Why? Because contrast and some of these other are used when we load satellite data. So whatever type of data we had so far was generated, was not acquired through remote sensing. So there is a section in this, and I think, Joseph, if you don't mind, maybe you can go and show and try to load some Sentinel scenes so we can see how to load the different type of data directly from a Sentinel. So this data that we have here right now in the layers, they all are stored in our store. But we do have external data because that's hundreds of terabytes of data. And in order to now bring this type of data, you need a bit more knowledge. So you all are familiar maybe with Sentinel satellites, right? They constantly scan the globe, okay? And they create these scenes. So essentially, when you want to find and load satellite data, what the system does is it talks a standard called STAC, which means Spatial Temporal Asset Catalog. It is redundant for you. I just wanted for you to know that this is a standard, and it is important because it tells us something. It's a spatial temporal, so that means we already have search capabilities in time. we have search capabilities in space. So our maps give us the space, and the time windows gives us the temporal interval where we want to search our data. As satellites produce data, it is stored in the cloud. And what we are doing in this interface, we are going and querying. Joseph is querying now and is picking, can you pick one band, for example? Okay, yeah, this is a specific band. Now, this requires a bit more knowledge, but we are demonstrating like how this is happening. So when by default the tool, when you want to load satellite data, things become much more complicated. Why? Because for every day, for every minute, on every location, you have different type of scenes, and you have different type of um, properties that you can use. And in order to deal with this with all this complexity, in order to load individual scenes, this is the kind of approach that is required. It's not enough to go and select population. When you select Sentinel, you load millions of tiles. And this map here, can you zoom out, please? So the boxes will disappear. The boxes will disappear because you're not supposed to even see them. You can't see and you can't interact with this data at any kind of zoom level. So Joseph selected one tile from one temporal interval, and this is one band because the satellite produces many kind of layers. This is a multi-layer type of data, and you can see these are the layers that basically exist in a Sentinel. So, for example, if you want to display something specific, this is going to be, we're going to dedicate probably a whole session to interacting with satellite data because it requires a bit more specialized knowledge. But in essence, this is what is required to interact and query satellite data. And now, basically, this is how we load this satellite data, right? He loaded it, and suddenly, in some instances now, the brightness, the contrast, all these features are going to help you to interpret. Maybe you want to locate something, maybe you want to see the extent of like the depth of the water, the clarity of the water in the lakes. With all the satellite, you can do lots of things. You can compute various variables related to terrain. So I think I'm going to stop here, and Andre, I think we're going to take a 10 minutes break and meet after that, and we're going to continue now with the vector type of visualizations for each type, for the point, for line, and polygon. And why not create at the end the map, see how we create a map, or just print the map content into a picture, save it into a picture.
Yeah, that sounds very good. Thank you so much, Johan and Joseph. Maybe we can take 5 because I think we're slightly behind schedule.
Yes, we can take 5 minutes. So let's meet in 5. Let's meet in 5 minutes, and we continue.
Great, thank you. Aaron. We'll start in 15 to 20 seconds. Johan, if you're ready, then it's your
Yes.
cue. Thank you.
I'm ready, and before we start, I wanted to say I tried to answer some question. There was one question from Basma Syed, and I'm very much aware of your point. It's a valid point. I recently read about the issue with, map projections are making Africa look smaller. It's a fact. But you have to understand that the reasons this is the case, it's purely technical. So the current map projection, which was created by Google, it wasn't it was chosen based on these properties. Namely, if you use this projection, every tile, every piece of screen has the same size, relatively has the same size in bytes. Suddenly you see we moved from map to bytes. Why? Because the map uses bytes, splits the world into small chunks and sends those chunks. Those are sleepy maps. If you change the projection, suddenly this relationship will change. They don't become mathematically nice, round, and the tiles don't become square. That's the biggest problem. This projection was chosen because every chunk of screen is a square, and squares are nice mathematically speaking. You can, if you take the power of two and other properties are really like mathematically appealing. If you change the projection, it's very nice, but you are going to hit some performance issue, and things definitely will look proper. That means Greenland, which is a quarter of, or maybe less of Africa, will really look like a quarter. But then you will have much more tiles in Africa and other parts of the world, which will bring some complexity into the system. So you have to understand that the motivation was technical, obviously, because the people who developed this were, they didn't necessarily care. They were not geographers. Google hired some computer scientists, and these guys didn't care the fact that Greenland is probably is represented just like Africa. Just to make a parenthesis, so we can move now on. Otherwise, we're going to be. So I'm going to start sharing my screen and continue with the vector visualization. Give me some seconds. I hope you can see my screen, if you can confirm.
Yeah, thanks.
Okay, so Joseph has, we started with basically we started with looking at the data store, what it can do, a little bit of how you can search what are the properties, and we looked at the main data types, right? So let's tackle visualization. So what I'm going to do now is I'm going to move back to the data section and just start with the first with my health sites. So this is my data set, and by default, the system allows when I created the data set, you made me notice that there is this change default appearance. So when you load it, the default probably was showing with some red circles or blue or random circles, but I didn't want that. So I altered it. So I give it like this cross, the Swiss, very much like the Swiss flag center. And because these are hospitals, these are health sites, right? So I wanted my layer by default not to be shown with a point, but with these nice icons. Now, what do you have to? There is like the point data has it's a little bit peculiar. First of all, speaking from a geographical science point of view, points are discrete, right? They have no area, right? So that has some advantages and disadvantages. You use these to show mainly very small, like objects that don't have area. While this is not true that hospitals don't have an area, obviously we know. At the geographic scale of a continent, you cannot show a hospital. That's why we choose it like a pharmacy. It's a building, but we show it with the area because we work and operate at a certain geographic scale. However, the point data type in geospatial science has some two other nice properties. So what we see here is it's a random distribution on the map of these points, but there is a different type of data. You know, if I ask you suddenly, like, where is the highest concentration of these health points? You know, you can see, yeah, maybe it's Europe if I zoom in, but then I zoom in here. Obviously, there's more points. Yeah, suddenly Europe doesn't seem to be so aggregated. You see, because there is conflict between these points, and the map is working a lot not to overlap symbols and labels and other stuff. But then we have a different type. If you notice, there are three types, three buttons here. A point data type based on your goal can be symbolized in one of three ways. As a simple point, that is what we see here by default, as a heat map. This one suddenly appears to be a surface. So what happened underneath? We kind of created a virtual layer of raster type, and we draw it on top of, instead of the points, we draw these areas and these areas are expressing the density of the points. So when you look at this, you can see, okay, there is like a red. Intuitively, we say red will have higher density with higher, and blue with less density. And this is scale dependent. You can see that it changes as I to scale. So these heat maps are very, let's say, technically are very tricky actually, and they are very misused in geospatial. They should be used, this type of visualization of points, one should use when you want to express properties like density on maps, the sheer like count of objects in a specific areas, and you have many objects there that are going to clash. That's when we revert to this, and it's very non-scientific. And I'm going to show you and demonstrate what it means. Like, people tend to think this is a scientific method. No, it's a visualization method. And it's very easy abused because it's not scientific enough, according to my at least own taste. And the last one is circle. This is very similar to maybe let me refresh, because it could be that my internet is playing. Can you still hear me, colleagues?
Hey on, yes, we can hear you.
Well,
if you can send me this link, I can also.
Yes, yeah. I realized that no, there was a problem. It maybe it was my browser. So this is the last one.
So just to say that maybe we want to also leave a little bit of time for the practical, just to flag to you time-wise.
Yeah. But for me, this is the practical. What it means that I'm explaining now, and we're going to add the map, and we're going to proceed to visualization in terms of practical. Maybe we didn't have the exact understanding. So what I'm going to do here, I'm going to start with the heat map, and let's move and let's bring it to the map. So in a similar way that, like my colleague, you can see that Joseph showed us. This is, the heat map type of visualization contains a couple of controls in the map that allows us to manipulate the layer. So, for example, when we click on intensity, we kind of give more weights to to specific points, to all of them at the same time. When we increase the radius, these are all relative. You can see they are relative numbers from 1 to 100. And basically, I suddenly, at this point, the image becomes very weird. You cannot understand. So if I restrict the heat map radius, basically, you can, at this would correspond to visualization at a specific scale. So if you set the map, I want to create a map at 1 million. 1 meter on the map is 1 million kilometers on the ground. I would set my heat map radius to specific value, but you can see there is I cannot advise you what the value should be. This is a relative interval from 1 to 100. And because it's visualization, you have to do it so it looks good. So this one looks good to me, and it shows a certain type of density. So I would leave it as this, and I would probably print this kind of map to show the density of this of the you know, of these points of health points. So that's why I said it's not scientific enough, because these values are not tied to the data. You're just using some arbitrary notions from visualization to create a visualization in essence. So, but it's very useful to show the density and these kind of aspects. And the last one, so basically, I basically brought this health site. So I'm going to type here health, and this is another way to health sites. This is another way. It's the same data set now. I'm interacting more or less with the same data set, and I'm going to bring this layer as a point layer, and now I'm going to switch to a circle visualization. So my goal here is to have actually the same layer loaded 3 times with 3 different visualization. And I can say, okay, here, like show only this layer. Okay, so this is the circle one. The circle varies a little bit by what can be changed. So the difference is that if you have a point and you want for some reason to create some strokes and an empty hollow point, this is what you have to use. It's very peculiar. You most probably won't need it, but you know, I have a circle stroke width, and I will give it a red color because I like red color, and the circle color, I will actually you know, I can actually make it based on amenity. I can, you know, I can create a couple of values or other type of you know, emergency yes or no. Okay, so let's put it back and use a constant color, and let's try to make it transparent. So here is how I make the color transparent. When I choose the color, there is a transparency dialog here as well. So suddenly I'm showing you the health points as you know, as empty circles. Now, one of the things that is quite interesting with this vector type of data is that we can filter them. Okay, so I will demonstrate now practically, Andre, filtering. So, you know, there's various type of health sites. I think this contains just a bunch of sites that I dumped from a project, health sites IO. But I'm going to create a new rule, and I'm going to use amenity property, which, and now the system has looked, okay, you know, every point has various properties. So amenity property has various values. And I want to select only the amenities that are pharmacies, for example. So right now I have displayed my, you know, these are my, you can see that the concentration of pharmacies, if the data is correct, is very much, you know, it's very different. And, you know, it's basically a way to restrict your data and to look and to do subsets inside the data, to disaggregate it. So I can use various type of properties. And how do I know what properties that I have here? If I click on any one of these pharmacies, you can see what are the main let's say the main you know, the properties. We have the amenity, we have the address, house, and the street. Okay, so these are the main properties that we can use to disaggregate, for example, the pharmacies. Let me open this again. So and in essence, you know, you can, once I created the rules, I can add more. This data is not particularly good. It's just a dump from the internet, but that's the beauty of working with whatever we found, and essentially, because that's what you will do in the end. You will find your health sites, and you want to create pharmacies map for some reason, and you can view. I'm saying the filtered amenity equals to pharmacy. So this is what I'm visualizing at this point. I can add more rules, or I can clear them. Another good thing about this is that we can apply labels. So if I go to amenity, I can actually show every point with its label, what it is exactly, and I can customize. There's quite a lot of power actually when it comes to this, you know, to how labels. Every type of layer, whether it's point, line, or polygon, features this label and has a lot of power, which allow you to select a different property to label things, change the font size. This is important. Like, okay, maybe we want larger. We have something called halo. So what is a halo in a label? I'm talking about this because it's not intuitive. This white area around, we have a white text. Why? Because I need to see halo color. This is what halo means. We have this tool here. This tooltip help you understand what this term means, basically. So if you point your mouse over this, okay, with health sites, and then you go to legend, you can see what it means. I hope that sometimes the explanation might not be the best, but in this case, let's make the halo yellow, okay? Well, let me go back to that because I didn't. So this is the text halo width, it's 5. Unless I change this. Either this is not working properly. Okay, let's try first thing the color. So the text, we change the text to red. Now let's try to create the halo color as yellow. Okay, so this is definitely not working. Oh no, it is working. I'm sorry. You see, it's easy to get lost here. So what happens basically? I'm putting it to yellow, but I have to click on this button and select the color, and only then the halo has been changed. So in essence, this is, this is like, these are very advanced styling properties for all the layers when it comes to labeling, basically. So this is, in essence, you have to remember you can change the property, which one you want. If we put, for example, I don't know, let's see dispensing, what it means. Yeah, yes or no. Most of the attributes are missing, but there is a yes. Okay, if we put like on address, for example, if it's insurance, yes or no, or whatever the data contains, probably it's empty. This is pretty bad data, I would say, and I specifically use it. There's a lot of data, and I use it. I specifically want it to be like that. Let's put the amenity back because this has some values. Okay, so you have to remember that every vector type of layer has a filter and a label next to an information, which the information panel allows you to download and gives you the information of this data set. But that information is only as good as the one who published. In this case, it's me or you. If you choose to upload and publish data, it's going to be only as good as what you put there. There's a minimum set of information required to publish a data set. And you have to keep in mind whenever you do this, that it's good to put as much as you can. Obviously, it's not always possible. Maybe sometimes you don't know things, or sometimes you just don't have time. That's a bad excuse. I use it all the time, but I'm a bad data practitioner in this case. And okay, so that's basically it. When it comes to labeling, and the good part about this, the system allows you. So properties that we are going to have here are basically slightly different based on lines and polygons. So and you see, this is a circle type of visualization. When I go to the health site, okay, there's some other things. You can see that I'm using this hospital icon. So there's a set of icons, which is, I'm not going to, this is very basic and simple. The color that I used is red. Okay, but I can actually also not use the constant color. I want to turn off this one and enable this one now. So you can see now my icons have been labeled based on amenity. And there's a lot of type and a lot of garbage here. That's why we have so many values. Okay, so let's pick a, this is, when you have this kind of unique values, categorical, you have to use qualitative color ramp. So you pick your colors from unique distribution. These are sequential distribution of colors in the same intensity and domain range. These are diverging. These are good to showcase negative versus positive, minus versus maximum, low versus high. And these are good to showcase differences and unique values. So this is, for example, by picking this, this is what are the different color maps that we have in the system. This is how you can judge it, how you can go about this. Okay. So here I have right now basically the you know all this map. Let me turn off this layer and let me move to the we have basically, I'm going to collapse. You can see I'm just collapsing. We have 3 headlights layer, so we're going to keep it as it is. And what I'm going to do now, and I ask you to do the same if you can. Let's type here, for example, grip. Grip is, maybe it sounds, again, it's a roads database. So we have a roads data set. And what we are going to move next is to look into what is the difference compared, because there's difference. Remember, points join together, form lines, very basic. This is a huge data set. Okay, I'm going to bring it into the map zooms out because it shows us the whole layer. So this contains, I think, 20 millions of polygons. Why? Because they are, it contains various type of roads. It's a global roads database, and its attributes are a bit peculiar. So let me see what I mean, what it means. I cannot even, okay. So these are the attributes. Actually, I was working right before this exercise to change these because some colleagues have just put this very cryptical attribute names. It's not a good practice when you publish data. What you learn from this, what I'm telling you right now, when you have data set and you publish them, if you put this kind of cryptical, like GP, RTP, this is a local, this is a local roads or stuff like that. So, but the column names are not good. It should be road type. RTP stands for road type. This I don't even know what this stands for. So I'm just replacing them from documentation of the data set with some better values. But in essence, I loaded this layer and we are looking at it right now. Now you already are familiar. We can basically, apply a filter. We can select the RTP, which is road type, equals, and okay, let's see, tertiary roads. So suddenly I was left only with tertiary roads. And I think, okay, you say the map, there's a lot of data here. So this takes a little bit of time, maybe also because of network, and it seems to be not reactive, but there's a lot of data coming in. It should be coming. I'm not sounding too convincing now. Let me remove this. Let me clear the filter. Let's see, it's cached. So we have it cached. But just like with the points, we have a constant color, and we can actually play around with line width. So, okay, I'm going to use the line width. This is how, for example, we can symbolize lines in GeoHub based on various type of properties. If they are numerical, we can use them to associate different property, the magnitude of the property with the width of the line. And you can see it's the same type of approach with intervals. You can control the line width, and this is the domain of the length. It's some kind of arbitrary system where the one, which is the thinnest, corresponds to a value of 4, and the thickest above 3 to something above 16. So why is this difficult to explain? Because I use shape length. So I use the length of each line in meters to say that the longer the line, the thicker it will be. My data set doesn't have other type like the width. That would be a very good property if we had a width of the road in meters. That would be very nice. It would be a very cool visualization. But you can see here, this resembles the other one. So you have to understand, you have to remember that with lines, we can change the thickness and their color. Again, I'm going to go with, I don't know, so let's try some of this. Okay, this is actually this is a property which is the road type. So let's pick up, remember when I told you road type is a categorical distribution variable. So we are going to pick qualitative distribution from this branch, and we are going to use this one here. Suddenly our roads, most of them are gravel, you can see in this, And this is basically what I'm doing right now. I'm visualizing. I can then go. The beautiful part about this, I can turn this no data off. I can turn this one off. I don't like dirt sand. So if I want to keep only one category, I can also control visually. I have some values that are specified. So paved is probably this category here, right? I can make it, I can change the paved and okay. So basically, we can also choose a pattern. So we have color, width, and pattern. With line is pretty simple. We can apply filter and do some labels, and basically this is more or less. It's very similar to points, and with the exception that we have this pattern, and we can symbolize and disaggregate it by color and by width. So let me collapse this as well. And now let's move to the last type of data, which is polygons. So if you type GHCL, which stands for Global Human Settlement Layer, we have created a admin1 layer, and we have aggregated 10 years of population data to this. So I'm going to bring this data set into the map and to also demonstrate how we work and peculiarities, how we work with polygon type of data. All right, we turn everything except this one, and we start to the polygon type is the most, let's say, complex of this, because in terms of size, it's the most complex, is the largest, so it tends to be a bit heavier. However, our web optimized, cloud optimized data format deals with this in a very nice, smooth level. So whenever you see, this is the most, probably in development project, colleagues, this is the most used bigger data set. So various variables in UNDP many of them are expressed at this type of level, represented through admin boundaries, right? So what can we do with this type of color? First of all, obviously we can filter them, but let's create a distribution map. You remember the population was a very peculiar visualization. This is the same. We are looking at population in 2010, and you can see that I picked some colors. So it's not really good looking map. Like most of the areas are equal, but I know personally that there's difference in here. So why is the problem? It's the same problem of population being skewed. There's very few districts that hold a lot of people, and the others, or provinces, the others are empty. Very few people living there. So because of that, if I'm going to already know, we already went through the population part, through the skewed variables. Just look at this. Suddenly, everything looks different, but I don't like the color. So in my case, I'm going to go for a diverging to show low versus high values. This is a good type. This is a good color map, diverging style of color map to show areas with high population as opposed to areas with low population on districts. Okay, let's see if we can do it here. Obviously, these intervals are pre-computed by this, but if you watched me, I was able to change it. So, for example, I can remove this and make it both intervals automatically. This is a detail that it might not be very. It's not very like it's not clear at all that you can do that. But just so you know, you cannot change the first and last, because they are tied to the data, but you can change the rest of the intervals manually as well. So this is in GIS literature, these are the most common type of maps, and they are called choropleth maps. So we take a variable and we map it linearly. It doesn't look good. We change distribution and breaks, and we bucket all the provinces or admin1 units into these buckets. But I don't like the color map, to be honest with you. I really don't like it. I'm going to go for a sequential, and I don't know. Let's go for this one. Okay, this is better. I might even choose to reverse it. No, this is not suiting me. So in essence, aside of this, the color and the ability to show and break down when we create choropleth maps, Aside, we have also this outline color. Now, I'm just going to say that the outlines are, in essence, these are they're lines. So because polygons contain lines, they can also be loaded as lines. So there's a possibility in GeoHub, and I'll show you immediately. You can see that I can bring it as 3D polygon or as a line, just like the points could be brought in as heat map as circle. The polygons can be brought in as line. So this is something in particular instances you might find very useful. The fact that you can show only lines, but you have a polygon data type. No need to convert into anything. The system will just map out. But the same thing can be achieved by for example, using a let's use a red color here. Okay. I set the outlines now to red, and let me go and create a constant color visualization and make this transparent. It's going to be the same effect. I'm actually showing polygons that are transparent, so I achieve the same thing. This is equivalent in essence. It's just another way to do this. Now the 3D polygon is more interesting. I will load them here, but we are going to have a bad time visualizing it because this is too skewed, essentially. So let's see what happened here. I need to click add layer. So now suddenly in my map, let me turn off this one and let's see what we can do with 3D visualization. We can use the population to basically change the colors, but we don't want to do that. What we need to achieve is to use a population to change the color. And take a look now because of the skewness. This map looks very like, you can see, for example, Greenland with no people and all the rest. There is some, this data set is very skewed. It makes it a bit more complicated to work with, but also I have to reckon that our tool is not good enough. It has to be better. You can enable the logarithmic aspects, but then everything somehow goes south. And there is a base height which allow me to lift this up. So okay, you can see that there is some 3D properties here, but it doesn't look very appealing. Let's lift it up higher. Okay, now I got somewhere. So in order to get a better picture now of this 3D map, okay, I'm going to apply a different, use a population schema with 5 classes, logarithmic distribution, and basically this is how my map. Let's go back to the base height and let's give it more base height and the height of the 3D polygon with more vertical exaggeration. But this is about visualization, and I'm not happy with how this works. If I disable the logarithmic, the values are scaled back. You can see the exaggeration doesn't really help. There's too much difference between these provinces. So normally, this is something I wanted to show you this because this happens when you deal with statistics. You transform your data. We didn't transform it here because the system doesn't have that ability. But okay, so this doesn't make for a nice map actually, and but if I was choosing to, there's other layers where 3D maps makes a very nice visualization. So I just wanted to show you this last aspect where it might be important or interesting is that you could create these kind of cartograms basically. If we had a better distribution, this would be looking pretty nice, and then we could zoom out and create visualizations like this, where you can see all the globe and 3D. But like I said, this is not easy to work with this specific type of population data. This because of the skewness. So let me turn this off and turn the globe mode off and set the map to 2D. Get back to the lines. Labels and filtering are part of that as well. But what I wanna show right now. So we have these layers here, but you can see that I'm covering. One is covering the other. Obviously, polygons are going to be covering other layers. So there is a way that we can we can arrange and we can control. There's this layer order. You can see this layer order, and from here, I'm going to try to bring, this is the top. I'm going to try to bring this. Okay. Let's see if I manage to do something about it. But I have to actually change. These are the pharmaceutical points. And again, this dialog here allows me to control each and every layer. And let's see, I'm going to put this to 100. Okay, this doesn't work. This doesn't work. Like it's not easy to work with it. I must admit that this is not easy to work because it should be changing, and I am changing, but then it's reordering them or something. Let's try to drag and drop. That would be another way maybe how we can control this. Okay, and now let's see if I manage to load the pharmacies. You can see now I was able to change the order. So there are two ways. You can either click on these buttons or drag and drop. So whatever is on top in the map is on the bottom. This is again probably not the one that is most intuitive. So this is how, one thing that I wanted to show you also. You remember at the beginning, we talked about base layers. Yeah, these are the base maps. So there is this checkbox here, show only GeoHub layers. What I see here right now is only my layers. But these crispy maps contains hundreds of layers. They are part of the base map. Normally, we never interact with them. But when we want to create various type of visualization with multiple layers, then this one, for example, if I uncheck it, now you can see all the layers that exist with admin boundaries from UN, with roads, with bridges, with everything. So there's more than, that's why the number of layers here is 179. There's 179 layers on the map, and it's still moving pretty fast. And normally we interact only with a bunch of, with a bunch of layers here. So when we have, let me change this visualization, and I want to change the transparency, put it back, and create a choropath map. I want to use population in 2025, and I want to use maybe reds. Okay, this is let's do the inverse if it looks better. Yeah, it looks a little bit better. It's a lot of red on the map, but this actually does the work. We can create 5 classes. Five is a kind of classical, and then we can also label this and create population 2012 labels. So on top of this, we have the heat map. This is the heat map, I think, or not. This one is the heat map. And let me just change the order of the. No, I wasn't able to drag it. And where is it? So I have admin population still not in the right place. Now, if the last thing I wanted to look into here is I think, Joseph, are you here with me? Can you hear us?
Yeah, I'm here.
Please take a look at this reordering. If you see if you can find the pattern, because I think there might be problems. There might be problems with this. Try to see while I try to save the map. So we have all our layers here, and they are stored in the browser cache. So what does that mean? That means if I refresh this, we designed the system to keep its layers. You can see that I still have 6 layers and I refresh it. I personally find it useful because it can happen that something goes wrong with your computer or something goes wrong. This is, we keep them in the cache. I have to physically remove them to go away. And even if I don't clear my settings in the browser, they will be there. Next time you start the browser, all these layers will be loaded. Some people might find it annoying. We have this. What I want to do next is to print. So there is at the bottom of this layer section, there's a save map and print. So when I click print, a new tab was created, and this is the page section, for example, that allows me. Okay, this is the page section, and this is what is going to be printed here. Okay, so I'll create a cartogram like this, showing some kind of perspective to laying this in 3D, and then you can choose the resolution. Normally the default values are pretty good. You can choose, we have a landscape. I could create a portrait here, increase the resolution 4 times, and there are some advanced settings made whether you want web PNG or PNG. So what happens now, and the format, obviously. So you can choose, A4 is classical that we do, but you can also choose a larger. You have to be aware that if you choose a very large one like A0, that might take a lot of time to process. So I'm going to click on this button, and essentially the system is just going to, or should create a picture. I should be prompted with a picture, exactly seeing the highlighted part in this. This process, you see the picture, the name is a Voyager, but I can give it any kind of name. I can save it, and okay, this is the picture that I created from the system. This is an easy way to export. Why I wanted to, well, there's one more thing I want to say, and then I'm open for questions. I'm going to save this map. So once I want this map, if I don't save it, if I save it, then I can reference it. I can make it private. I can make it public. It has a name by default, and I don't want to call it etc, but admin1, let's call it Academy 4. And I want to make it only visible to you colleagues because I select only with UNDP, no public. And basically I saved it. So this map now gets saved in the system. And basically, if you go then to the map, I want to discard all changes. The map shows up here. This is, again, I'm going to do a list-based rendering. This is the map. It's a first-class document. It contains the layers that we had there. And this is a very easy way, because just like data, we also have links. So this is basically where your map lives. At this URL, we are always going to be, unless you delete it, you're going to be able to open the map. Okay? So keep in mind that this map is not public. So if you want to basically change, you have to edit, sorry, no edit. I made a mistake this time. Edit metadata. I have to make it public. In this case, you can share it with anybody, theoretically, who has internet. Why is this good? Because you don't need a license. You make a map public if you can. Obviously, you have to consider any data. The map will tell you that you might have private data, and then there might be issues. Why? Because some of the layers, for example, might not be public. So if you have this kind of situation, the system will tell you, hey, you are doing something maybe that I don't expect. You have a private layer and you are making a public map, and you put it in the public map. So you will get a dialogue or something, and it will let you know that cannot be, that layer will not be visible, essentially. So now I made the map, I made it public. I'm going to update it, and this is now saved, and the document becomes available. So what is the value of this? Basically, developers can, you can use this URL here to create a picture of your map directly just by changing the width and height. You can render it and you can share it with colleagues. You can render it into a picture and put it in your documents directly by putting these numbers here, right? If I type here, I don't know. Let's actually see how that will work. I'm going to copy this URL. I'm going to paste it here, and I'm going to say that I want a 400 in height, and I want a 600. This is already decent size. And now the service is going to create a picture, hopefully, of my map. And okay, that is, yeah, I made a typo. You can see it's 4,000. That's why it looks so weird. Let me put it 400 back. So it created a yeah. So this is okay. This is the picture that the picture of the map. The labels are not there, and this is a bug. We tried to fix it, but there's some underground technical issues why those labels, and this is a problem. I would say yes, but I believe we will focus on it, and in future we'll fix it. But in essence, you can this is a very simple way to render the map. But when you open it, when you paste it, when you just copy and paste the map by itself, you can send it and open it. I know this sounds very simple. You click edit and you open it, and your colleagues will see more or less exactly what you had there. Your layers, the order of the layer, which one are turned on, which are turned off, and basically everything else. So let's visualize this is the heat map, and you can create a cartogram like that. I'll stop here. I think there's not much time for questions, but I'm willing to answer if you have any.
Jon, there's one question in the Q&A box from Rajarshi. In terms of using the high-resolution satellite data, which is difficult to load in low bandwidth settings, are there any alternate approaches that you would recommend?
So you're asking the question is whether there are alternate systems or ways how to load it, or
Yeah, so satellite data can be like very big. If
yes,
you're in the low bandwidth area, what would be
yes.
alternate approaches to get that data in some fashion? Or a lower resolution
So
version of it, or
yeah,
whatever.
so here's the deal. This is not like always. This is very nuanced. The fact is like this. The system is deployed in Azure. It could be when you access it from a very low bandwidth area. Most of the time, it could be localized. So that means we deployed it into US or Europe, but it will be made in the copy and put into some servers in Africa, so it reaches you closer. The system doesn't have issues with the data, and that is doing the heavy lifting. So the problem becomes the rendering of the screen of the browser. Your bandwidth doesn't affect the way the GeoHub fetches data, because GeoHub is in the cloud, data is in the cloud, super fast speed. What is slow then, and it doesn't, your bandwidth doesn't have any effect on how GeoHub handles this data. What was there is that the rendering of the map and browser on your computer can be affected. So you might not have a reactive system, but the system is reactive. It's just your browser will make it appear as maybe clogged, bugged, or something like that. That's the best explanation I can provide.
Thanks, Johan. Colleagues, and now we are at time, and I see one more question from Bunyod. Bunyod, would you like to come in to ask your question, or would you like me to read it?
Yeah, it's just about one of the tools called Story Maps, and I found that just by looking at it, find it very interesting because it's dynamic and As I understand, these are used to for presentation purposes when you want to like present a story which is based on geographic data, where you need to show where this data is located and this kind of things. Because we haven't had time to look.
Yes.
Yeah.
Yes. I know we will have other sessions which will be dedicated to these. They are story maps. So essentially, this is true, absolutely true. The story maps are hard. And in essence, a story map is just a map that is predefined and zoomed dynamically with some extra context. So let me pick a better one, and let's take a look at the better one. We have I don't know. There are mainly tests, but let's pick up one. Maybe these Zanzibar tourism attractions. So I'm going to view it. So basically, the system allows you exactly to create this, and you can see once I zoom in, okay, you see the background map has changed. There is a text, so it's exactly like that. You can use one map and then position it to showcase your use case, or you can combine 5 maps into a story map, but they have to exist, right? You have to save them before, and that would yield a very complex story map. But essentially, this is exactly, I'm visualizing one, and let me show you more or less, like if I click edit, it looks like PowerPoint. We try to make it like PowerPoint. So this is the first page, and you have these settings. And this allows you, for example, you see the story map has been reset. And here I can move to the map and look, all these are properties which allow me to, enable map to be interactive. Right now it's not interactive. If I do this, basically, I made it interactive. That means I can move now the mouse and I have these controls on top. So let me put it back. I can choose to put a legend. I can choose to hide it. And then the cards. These are the cards, for example. Okay, we have test 1 and I don't know. Yeah. So in real time, it changed. Then we can preview it. This is not always working perfectly, this preview. But in essence, we try to do a preview real-time rendering. So yes, these story maps are next step where you can then create some maps and either use one map in different, like zoom, in 3D, in variable, because there's a lot of properties and parameters. You can put the globe mode, you can select on off layers, you can rotate it, you can create animations, and then use the card section to insert pictures and text as a context information to create a story map to tell your story. So absolutely, you are absolutely right. And I believe, Andre, next session, we might actually look into this one. And have a full, like 1.5 hours, 2 hour session about the story map.
All right, thanks, Johan. Next session is with the Crisis Bureau colleagues who will be talking about multidimensional data and overlay. But we'll see what additional material we can put up on SparkBlue for colleagues to have a look at, as well as some practical exercises that will actually guide you step by step through a lot of the things that Johan and Joseph covered just now. I know we're a few minutes over, so thanks so much for staying to all 43 people of you, and we'll see you again next week.
Have a great day, everybody, and thank you for joining.
Thanks, everyone.
Thank you. Bye.